Hey, what's up guys? In this video, we are going to solve this Leetcode problem 201, course schedule number 2. So it's fairly similar to course schedule number 1, and but it's a little bit more than that. So let's say the example in here, number of courses is equal to 2, and so we have total 2 courses, and that they are being course 0 and course 1, and course 0 is the prerequisite of course 1. So we need to output the order in which we would be taking the courses. So in this case, as you can see, we have to take course 0 first, and then take 1 because 0 is the prerequisite of 1. And in this case, example number 2, as you can see, 0 is the prereq of 1, 0 is prereq of 2, and 1 is a prereq of 3, 2 is prereq of 3. Right, so as you can see, before taking anything, we take course 0, and then we can take 1, and then we take 2, because and then after that we can take 3 because 2 is a prereq of 3, so 3 comes after 2. At the same time, and 1 is a prerequisite of 3. So we have to take 1 and 2 first before we're taking 3. Right? And also another correct answer could be 0, 1, and 2, and 3. Right? Because 1 and 2, they don't depend on each other. So this is example number 2. And example number 3 is a trivial case and just only one course. And there's no prerequisite to take that course. Yeah, so, and this question was asked by, well, it's a fairly famous question, popular question. So Amazon and Google, Microsoft, and those big names love this question, obviously. So let's solve this question together. So we first need some prep work. We need a prerequisite dictionary, and so the key being the course number, and then have an empty list to start off, because each of the list will be including all the prerequisites associated for that course, and then after that we just fill up this dictionary by using this one. So we looping through all the prerequisites, and each one is like is a list. So this is a list of a list, and each of the list will be have a course and also the prerequisite for that course, and then we will append that to the list associated with that course. Right, so it's just some preparation work, and then after that we will do a DFS, and that will be going through each of the courses, and yeah, we will do that together. And we need two helper sets for us. So one is a taking, so basically keep track of what course we are currently taking, and also another one is a cycle. So basically we use this to detect any cycle in the courses. So for example, if the prerequisite list looks like this, let me show it to you what I mean by cycle. It looks like this. Sorry about that. Yeah, so as you can see, course 0 is a prerequisite of course 1. At the same time, course 1 is a prerequisite of course 0. So we can see a cycle. So there's no way we can do that, because we have to take one and then have to take the other one first. But the other one is also prerequisite of this one. So you can see it's contradicting. That's why whenever there's a cycle, we have to exit from this function and return a false. Okay, so that's why we need this cycle set. And this if statement helps us to do exactly that. And sorry, so that the name of that first set should not be taken, should be completed. So you keep track of what course has been completed at that point. So if that course in the completed set, and we will return a true. And this will be very helpful when we keep track of all the prerequisites. If we see that all the prerequisites has been completed, each one of the prerequisites have been completed, and we're good to taking that particular course, right? And when we are doing a DFS, it should be DFS, and we will temporarily add that course to the cycle. And then at the end, after we loop in through all the prerequisites, we will remove it from the cycle. And then now the problem comes from what we need to do is to fill out the things in between where we will do all the prerequisites and do DFS on all the prerequisites, right? So as you can see, this is how we can do DFS on all the prerequisites. And just using, and this is why we need that list in that dictionary. And this is exactly how we can do a DFS if this guy return a false. And what it means is we detect a cycle and this automatically return a false. There's no way we can complete it like this. Because there's no way to complete all the courses if there is a cycle. That's why we return a false. And also, after we finish all the prerequisites, and then we will finish the course itself, right? So in that case, the completed set, we can add that particular course after we adding all the prerequisites, and then we add in that particular course, right? Because when we call the prerequisite, it's already they are already in the completed set. And also at the same time, we can do we can append it to an answer, which we will return at the end. So again, before appending that course, we already append all the prerequisites already, right? And after that, if there's no prerequisite returning a false, and that means that we finish all the prerequisite in the course itself, and in that case return a true. Okay, so that is basically it for the DFS function, and next step is gonna just trigger running. So for the course in this is how we can run DFS through all the courses, and this guy returns a false, that means there's no way to complete all the courses, and just return an empty list. And otherwise, we return answer. Sorry, I found a typo in here. I need to put a range in there, and because otherwise it doesn't loop through all the possible courses. And let's run it. It works, and let's submit it. Oops. Hopefully, perfect. It runs. It's pretty efficient, as you can see. Yeah. So this is the approach by using DFS. And in terms of time complexity, it's a BOV plus E, and this is from the official solution. And V being the number of verdicts, and then E is being the number of edges. So basically, so it's essentially we iterate through each node and each vertex in the graph once and only once. So basically, saying is the V being the number of courses, and E is being number of the prerequisite relationship. Because we only do it once, and because we never do it again, because there is this complete set. So as soon as we look at one particular course, and we look at all the prerequisite of that course, and also the prerequisite of the prerequisite. So it's like a chain. It looks back all the way to the origin, which has no more prerequisite. So that's why we only work on the graph once and only once. For the space complexity, as you can see, we need a completed set, also a cycle set. So I would say the completed set is a big of a number of courses, right? We keep track of how many courses we are completing along the way. And also the cycle would be the number of relationships, prerequisite relationships. So this is basically the V plus E. So it says we use the adjacency list to represent our graph initially, and the space occupied is defined by number of edges because for each node as the key, and we have all the adjacent nodes in the form of a list as a variances. Yeah. So this is basically what we just said, right? Okay, so this is so much about this solution. I hope you like it. If you do, please like this video and subscribe to the channel, and that will be a much great help to grow this channel. And yeah, hopefully I will see you in the next video. Thank you for watching. Bye bye.